Okay, question number 10 from our shadow mock. The height above ground in h meters on a roller coaster is given by this differential equation. Notice the mix of h and t. Okay, so what does this one say? T is the time in seconds from the start of the ride. At the start, the passenger is 6 meters above ground. So they've been very nice to make it as explicit as this. First part, show, notice it says h rather than, and this is dh dt. So what we need to do here is, first of all, we're going to move the pieces so that we have separated the variables. The dh is going to stay where it is, and then the h pieces are going to move to the left-hand side using multiplication and division, sometimes some factorizing. And the dt piece is going to move to this side. So that's going to be our first step. So let's do that. So 1 over 0.045h dh will be equal to cos 0.3 dt. So this is the first step. It's called separating variables. So all the h's with h, all the I think we've missed off the t there. All the t's on the dt side. Okay, just out of interest, I put this on Desmos so you could see what was going on. So yeah, that does look a bit like a roller coaster, doesn't it? So show this result here. The next stage we want to do is we want to integrate both sides. So they're sort of integration questions in their own right that we just work out. Okay, so how about over here? Well, the first thing I would say is I'm going to think of this number as sort of going on the outside, and then I'm going to think of the h on its own as 1 over h. I think that's an easier way of doing it. So let's do that now. So I'm going to say that this is 1 over 0.045, the integral of 1 over h dh, and this is going to turn into natural log in a minute. Okay, which also sort of explains why the e is there. And the right-hand side, so we had cos 0.3. So it's got something to do with sine. Sine goes to cos. The argument bit in the inside is going to stay the same, so the 0.3t is going to stay the same. The problem is the number at the front, isn't it? So if you did sine, it would turn into 0.3 cos, and there's no 0.3 at the front. So I need to compensate by doing 1 over 0.3. And if you just check for yourself, you'll see that that works nicely. The chain rule will make those bits cancel. Finally, we're going to do a plus c on the right-hand side. So we've separated variables and we've gotten it ready to integrate. I haven't actually integrated my left-hand side, have I? I've just noticed that I've missed that. So what we're going to do is I'm going to finish off this bit here, and then I'm going to sub in this condition. So it tends to work best when you sub this condition in immediately after you've finished all your integration. So let's go down here. Let's just carry that on. So it's 1 over 0.0, how many noughts? 45. And natural log of the absolute value of h, I'll just double check that, yep, equals, let's finish this off, 1 over 0.3 sine 0.3t plus c. Okay, so we said that we were going to sub in this condition. So always read your question carefully for this. It happens a lot in mechanics questions as well. There's some information that conceals a known value that helps you find out your c. So when h is 6, t is 0. When h is 6, okay? So if we sub in the h as a 6 there and the t as a 0, okay, this will lead to what result? So what's the let me just have a think about the neatest way to handle all of this. I think just before I do that, just for sort of quality of life, I'm going to bring this one up here, and I'm going to write 0.045 here, so I don't have to keep rewriting this fraction. It's getting a little bit annoying. So now let's sub in the 6 and the 0 now. So if I put that one in there, can you see that I would end up with the result that the natural log of 6, I can just drop these modular signs because 6 is already positive, it doesn't do anything. The natural log of 6, all of this will disappear because it's sine of 0 and it's multiplication. Okay, so that will end up being the c value. Yeah, the natural log of 6 will end up being just the c value. So now I know that, I'm going to rewrite the previous line with that c value in. So it equals 0.045 over 0.3 sine 0.3t plus natural log 6. Okay, so that's what I would do as my next step. And what do we need to do next? Okay, so h equals, so I'll need to get rid of that. 0.15. I wonder if this has got something to do with 0.15. 6. 6 natural log of 6. Okay, so how to handle this? Well, first of all, let's just confirm that looks like that looks like that is going to give us 0.15, so that's really good. So that's 0.15 sine 0.3t. How to handle this natural log of 6? There's quite a few ways of doing it. Probably the easiest way to do it here is you actually temporarily take it away back to the other side. So the nice thing about log rules is as long as what you're doing is following a rule, it should see you over the line. Now, why am I doing this, you're thinking? Well, now I've got those logs together, I can do the natural log of h over 6, can't I? Equals same as before. Now, why is that good? Well, that's good because if I do e on both sides now, I'll cancel that. I'll get, let's write it out, I'll get my 0.15 sine 0.3t, and I can move the 6 back up, do you see? So the h is going to be equal to 6e to the 0.15 sine 0.3t. There's other ways I could have handled it, but that just seemed to be what happened when I went through it, okay? So there we go. That's going to be my result. So state the maximum height above ground. The maximum height. Okay, that's an interesting question because E, we normally think that E can just go on forever and ever. So why is that not going on forever and ever? You can see that in the picture that it doesn't go on forever and ever. Well, it's got to do with the fact that sine only gives you certain values, doesn't it? It gives you values ranging from -1 to 1. So which of those values would help this the most? Well, 0.515 times 1 seems to be the answer, doesn't it? So I don't think having a 0 would be helpful because it would be e to the 0, it would be 1. I think it's going to be... Let me have a little think about this for a second. Is that the best value? So 0.15. See, anything else I do, anything else I can do, unless I do a 0, 0 is going to give me 6. So what you might want to do here is you might want to throw a value in your calculator. You might want to just test that if you do 6e 0.15, that it is greater than 6. So let's just do that because that's what I would do in an exam if I was a bit sort of stressed out and I wasn't too sure. So if I do 6e to the 0.15, which is when this part is 1, I get an answer of 6.97. So it's bigger because what I was just testing in my head, if you're wondering what I was thinking about, is I was thinking about what happens if you put a 0 in there because that's 0, and then that's 0, and then that's 0. So it becomes 6 times 1, it becomes 6. So I was just doing a bit of thinking about it. But I am going to get the biggest value when I get, what was that? When sine, when sine of t is equal to 1, I'm just checking in the question, I don't see anything that's going to stop it. When sine of t equals 1, the height will be equal to 6e to the 0.15, won't it? Because the sine part will be just contributing 1, that's what I'm saying. And that's the biggest value. So that would be around here, for example. Okay. So an interesting range question. The passenger reaches the maximum height for the second time, t seconds, the second time, t seconds after the start of the ride. Find the value of t. Now that is an interesting one. It might be helpful to think about the first time when this happens. So the first time is when 6e 0.15 is the answer. I'm going to show you something that lots of students do. Is they would set this equal as the h in here, They would set this equal to 6e to 0.15 sine 0.3t. But can you see that if I do that, 6e 0.15, I'll put a 1 there. Can you see that really what you're just solving is you're saying I'm interested in the point when my sine graph is equal to 1. Or when is a sine graph normally equal to 1? It's normally at pi over 2. So you're really saying to me it's when pi over 2 is equal to, well, it would be t, so it's going to be 0.3t in this case. So this is the first time at which it's going to happen. This gives you a t value of t equals, is this 5 pi over 3? I'm just doing some thinking about that. Yeah. So that's the first time when it's going to happen. And you might be thinking, well, why is that useful? Well, if I know the first time that it happens, and I know sort of the wavelength of this, I can just add this on to the next one, to find the next one. So I would normally add 2 pi, wouldn't I? Yeah, that's what I would normally add on. But because this has been stretched, it's not quite going to be 2 pi. So how is the 0.3 going to affect it? So what's the best way to explain this? Well, the 0.3 is going to slow this down. Yeah, if I had sort of like sine 2t, remember, that would make the graph sort of move through its cycle twice as quickly. And what I would do then is I would divide that by 2. So it would repeat itself every pi rather than every 2 pi. So how am I going to handle the fact that it's not sine 2t, that it's sine 0.3t? Well, I suppose then I'm going to do that, aren't I? Because that's the pattern of what I'm doing. So it's 2 pi divided by 0.3 added on to the first time that this happens will then tell me, the second time that it happens. So let's do that one, shall we? So if I do 2 pi over 0.3 and I add on 5 pi over 3, apparently I get the answer, is that 25 pi over 3? So let's just think about that for a second. 20 over 3. Yeah, because this is 20 pi over 3 added to 5 pi over 3 more. So that answer makes sense. Okay, so that's my t value. But what on earth does that actually mean? Well, it's in seconds. So I need to just convert this to seconds. And the answer for that is 26.2 seconds. So quite a challenging question, really. Very challenging for 2 marks, that one. But it plays on ideas of transformations of sine graphs. So there you go, differential equations leading into ideas about range and domain, I would say, and graph transformations of sine graphs.